Welcome back. We're still working with weak acids and bases and seeing what we can do with their acid constants. Calculate the ionization constant for each of these acids using the information provided. Okay, so this is not so different from the previous couple of practices. In question A, we know we can find the acid constant for a weak acid if we have its hydrogen concentration and the concentration of the original acid, given certain assumptions. And the acid concentration started at 0.10 before it hit the water. And the hydrogen concentration, oh, they actually gave it to us this time. I was about to complain about how we'd have to do 10 to the minus pH, but not this time. Lovely. 6.3 times 10 to the minus 5 moles per liter. And have to square that. So, calculator punching ensues. 6.3 times 10 to the negative 5 squared divided by 0.1. My calculator kind of runs out of decimal places for this, so all it's showing me is 4 times 10 to the minus 1, 2, 3, 4, 5, 6, 7, 8. Not fantastic. This could be 3.5 and I wouldn't even know. So I apologize for not using fantastic tech here. If you've got a better calculator than me, you're probably getting a more interesting picture for that acid constant. But that's my calculation. And for B, same thing is happening. The hydrogen concentration is 1.4 times 10 to the minus 3. Don't forget to square it. And the original acid was 0.15. This is not the most common thing that we'll do with this formula, but they're starting us with the basic version, I guess, which is fine. Divided by 0.15, and I get 1.3 times 10 to the minus 5 for the acid constant. Now, they told us what these acids are, so you could kind of check your answers against the data book for this. Where's my acid base table? The first one was hypochlorous acid, HOCl, which is roughly halfway down the second page of the acid base table. And did not, oh, 4 times 10 to the minus 8. I take that back. I was looking at the wrong row. Yeah, okay, so the data book agrees on 4.0 times 10 to the minus 8 for this. So happily, my calculator rounding didn't hurt us in this case. It could have, it just mercifully didn't. And this is what? Propanoic acid, which is like a quarter of the way down the second page. It's listed as 1.3 times 10 to the minus 5 in the data book, and mirabile dictu, that's exactly what we found. So, hooray, it works.